let me just give you a little bit of background on Portworx for those of you in the larger audience that are new to this. We were sort of founded alongside the Kubernetes project, right, with the sole intent of enabling stateful applications on the Kubernetes or cloud-native control plane platforms. Our mantra has always been any, meaning we are an application-focused storage company. We support any application that runs in the Kubernetes control plane. We support any Kubernetes distribution. We have customers that are running us on-prem, large-scale clusters, for example, with OpenShift in the public cloud on EKS, GKE, Amazon, and so on. And we actually support any infrastructure. We run in any cloud. We run on any kind of backend hardware storage infrastructure. Obviously, here we are with Pure, but we will support any kind of SAN or commodity servers with direct attached drives. The topology and the storage technology, we are agnostic to that. What we are going to talk about today is really the core Portworx product. And at the core is the software-defined storage control plane that is meant to work with any kind of storage backend. Most of the times we deploy pxstore, which is our core Kubernetes-focused cloud-native SDS. So it is software-defined storage, which is designed from the ground up to support cloud-native applications. What do I mean by that? I'm going to contrast this with other software-defined storage technologies out there, which really are designed to support machine-centric workloads. So obviously you're familiar with technologies such as Ceph, and there are a number of other products like that. They're all great products, but their design intent and workload is slightly varied and different from what we're going after. We're going after cloud-native applications, which are applications that are inherently distributed in nature, microservice databases such as Kafka, Cassandra, Elasticsearch. Secondly, these applications are packaged as containers. So the workload we're going after and the use cases are very different. And also, we're designed to run on any kind of infrastructure. And a lot of times, our customers will run us both on-prem and in the public cloud. So we'll be focusing a little bit on those hybrid cloud type of deployments today. You may be familiar with our CSI, Pure's CSI interface. To the various backend arrays, FlashArray and FlashBlade. The PX control plane can support that as well as it can work with other CSI providers. There are some core modules that provide Portworx the advantage it has in the Kubernetes stateful application space. And those are the 5 modules you see here in the data service platform box. Our backup DR migration modules are critical to running enterprise-grade applications in production, especially when people are managing fleets of clusters. And I'll also focus a little bit about how we enforce security at a namespace and container granular level by working with any kind of key system. And Autopilot, which is slightly newer functionality in our product family, but its goal is to bring this element of AI into the platform so that people don't have to worry about how to manage the backend storage or go through the storage admin kind of tasks that are typically needed to run these applications at scale. Before I get into the demos, I just want to set the context here a little bit philosophically. Our way of looking at things. What we see as having happened and why we even started Portworx is that this move toward Kubernetes is a lot more interesting and deeper than it appears at first brush. What is happening in the enterprise space is the shift from a machine-centric control plane, which is typically led by VMware, where all of your objects that are being managed are machine-centric, right? So if storage has to be provided, it's storage for a machine. If you need an IP address, it's an IP address for a machine. If you're securing something, you're securing a machine. And that's not really how modern application developers and enterprises think. We realize that the most important asset in a data center is not a machine, it's the application. And so Kubernetes lets you think application focused. With pod networking, you're providing and managing networking at the application level. You're securing your applications, not machines. And similarly, when it comes to storage, you're providing storage to application containers, not to a machine. And so Kubernetes does a lot more than just orchestrating containers. it manages your infrastructure too. And when you start thinking that way, you realize that you need a different architecture for storage. And that's really what we started with. The Portworx storage overlay, which is called pxstore, and I'll be focusing on that in my first demo, is software-defined storage, which is designed to run inside of the Kubernetes control plane. What I mean by that is it is the first storage solution that runs adjacent to your application containers on the same workstation machines where the Kubernetes worker nodes are running. So we have maximum knowledge with respect to what Kubernetes is trying to do. We're very tightly integrated with the Kubernetes control plane. And I'll be discussing this module called Stork. You could Google this. Stork for Kubernetes stands for Storage Orchestrator for Kubernetes, which is what provides that level of application intelligence and control plane intelligence into Portworx. What does pxstore do? Pxstore does two things. One, it manages your backend physical storage, whether it's servers with commodity servers with locally attached drives, or be it a SAN. Again, it could be any SAN, NetApp, Pure, EMC. We work with all of them. Or in the public cloud, it could be the cloud provider's storage, right? EBS drives, managed disks, Google's persistent drives. We work with any of these backend storage, physical storage solutions, and we virtualize it. And the pxstore SDS, it provides container granular virtual volumes. So the containers are not talking to the backend storage directly. They get virtual volumes from the Portworx storage overlay. I'll be demonstrating how that works in my first demo. From here, all of the provisioning of your storage is happening directly through Kubernetes. Application owners, end users are not directly interacting with Portworx at all. They're just doing things through Kubernetes. Portworx and Kubernetes will communicate with each other to make the correct provisioning happen, to make the storage available wherever the container needs to run, and durability. If there's something going wrong with the backend storage, drives are failing, or the performance is not where it needs to be, Portworx can work with Kubernetes to take corrective action to ensure that the application continues to run. So the emphasis is on supporting production-grade workloads.
Sorry, just want to quickly ask a question about not just this, but also in a way about the hardware side of things as well. That does that mean that this overlay and I think there was I can't remember the term, but the hardware layer above that, the storage driver or control. Do you have to write compatibility into the product whenever a new storage mechanism comes in? Because different storage, also depending on the hardware that is beneath that, like spinning disk or SSDs or different products, they change and grabbing performance out of that, because every device has a different characteristic to extract most performance out of it. But also when cloud storage, the different kinds of cloud storages come along, each with their own characteristics. How long does it take for you to actually do that process and make it available to the market?
It's a great question. So the first answer is yes. A large part of our value is that we are taking on that hard work and that functionality and providing it first of all, in such a way that it is easy to consume in the Kubernetes control plane. But secondly, the Kubernetes platform administrator does not have to worry about the different kind of storage backends and tinker with it. So in the absence of Portworx, somebody has to your point, go figure out how to make Kubernetes maybe provision storage off of a certain type of EBS drive. So as you mentioned, there are different storage technologies within the cloud providers themselves. An example, Amazon has GP2 volumes, our provision IOPS, our instance local store, and they are constantly introducing new storage types all the time, and each one have their own nuances. We do take some time to be able to benchmark and work with these different systems. We deal with the backend storage at a common protocol layer, which is just block. We do not expect anything out of the backend storage other than block. So an example is this. We don't try and leverage the backend technologies, for example, snapshot providing mechanism. We assume that it cannot do application consistent snapshots, so we take on that functionality. So pxstore, think of it as providing a common denominator layer of functionality across any kind of backend storage system. And then we optimize for the nuances that we know about that storage technology. So for SSDs or NVMEs, you handle, for example, and you guys are storage experts, there's this thing called discards, which is what happens when somebody deletes data. And so there's more efficient ways to handle discards. And we take over all of that kind of knowledge that we have about the backend storage. So if a vendor put out a new storage technology out there tomorrow, we work with it right off the bat without any change because we're just assuming it's block storage. And then we have the ability to optimize for it when we work with that vendor. We've done some work with the Samsungs of the world and Intel and so on.
Another quick question. So and if you're going to get into this, just let me know and we can move on. Are you replacing the persistent volume claim, or are you inserting yourself into it ahead of it, behind it? Is it, or are you just taking the whole PVC and making it, because you just said that you're also doing application level consistency of the set. So I'm assuming that you're like in there in several different layers.
Great question, Chris. We are a persistent volume provider. So when Portworx is deployed, a set of storage classes are provisioned. I'll actually be demonstrating that in my demo. And whenever a PVC is created, the actual volume claim behind the scenes is coming from Portworx. And it is at that layer that we already have this knowledge about which application that volume is part of. An example is this, if somebody deploys an application stack that consists of, let's say they're deploying Cassandra, and there's a half a dozen containers running on 6 different worker nodes, we know that each one of those PVCs are not in isolation and are part of a family. They're part of an application group. So if we had to take a snapshot, we have the ability to take a snapshot of those 6 PVs, a point in time consistent. In fact, we even have the ability to go in and quiesce the database and flush any data that's sitting in the container's memory before we take that snapshot, because Kubernetes has communicated to us ahead of time that, hey, this is actually a Cassandra application. And I'll show you that in the demo.
Awesome. Thank you.